Hello, everybody. Welcome to IST 110. I'm, of course, Professor S, and this is today's lecture, though it is very short because the idea is I gave a short lecture today because I wanted to give people some time to work in their groups because the video is due Monday. So what we're going to do is I'm going to talk about the lecture and then I'm going to say a few reminders about the video, and then that's going to be it. So first thing is computer thinking, and we're going to start off with talking about computational artifacts. So what is a computational artifact? Really, it's something that is made by a computer, right? So I'm not saying it's like authored by a computer. What I'm saying is it's something that is made on a computer. Okay, so like it can be tangible or it can be intangible. Let's go over some examples. So a tangible example is something that you, like, let's say you type up a paper and you print it off, right? I'm not sure how many papers you're printing off and submitting that way. That's not usually how assignments are graded these days. But the idea is it's like it could be printed off. It could be a print. It could be a something that's a picture that's printed, or it could be a 3D printed sculpture. There's lots of things. The idea is like it's tactile. You can feel it. It's something that is tangible. Intangible would be like music made on a computer. Images that aren't printed off, like let's say you take a selfie and you post it on Instagram. You just made yourself a computational artifact because it's something made on a computer, but it's intangible because you can't really touch it. You could touch your phone, but you didn't make your phone. You made something that's on your phone that's intangible. Okay. Now, computational thinking is how you use computers to solve problems. And there might be other ways to kind of represent these steps, but essentially, computational thinking uses each one of these 4 things. And it might have like more steps, it might have less steps, it might have different names for them, but it's essentially the same process. So let's kind of go through this. So first of all, decomposition. The decomposition is the breaking down of complex problem into a series of smaller or simpler problems, right? You have yourself a big problem, and you're saying, all right, let's break it down. This is an issue, this is an issue, this is an issue, this is an issue, and you just do that, and you kind of think about how are we going to solve it? And then you look for patterns. This is the next step, pattern recognition. So you look for patterns to see like how like some common characteristics among the different problems within the same problem. Recognize these patterns can further simplify the problem, right? And then once you get into that organization, you start coming up with algorithms that could be used to make that happen, or coming up with the algorithm that can make that happen. Algorithms are a sequence of instructions used to solve problems, perform tasks, or in a structured manner, right? It's kind of like recipes for a computer. And then abstraction, that's when you think, all right, we can do this with other things, okay? So the example that I tried to give is the question is 111 prime? So that's our big problem. So we break it down and we say, all right, what is a prime number? And so how would we do that? So we could test all the prime numbers less than that number to see if any of them divide 111. Okay? And then we go into the pattern thinking. We think about like, well, do we really need to divide all of them? Because the idea is 10 times 10 is 100 and 11 times 11 is 121. So if we think about anything above 11, it would have to be something less than 11, right? So then if we think about it that way, then that means we would only have to if it's not divisible by anything less than 11, then it's not going to be, then it must be prime. Okay? So then we come up with an algorithm that says, all right, find all the prime numbers less than 11 and divide by 111. And if you get any integer quotients, then not prime. And so that will work. And then we think about, well, you know what? This doesn't just apply to 111. This can apply to any number. And so that's one way that we could be using to come up with a prime number. Now, notice I didn't use computers, but the idea is it's using the process, right? And I'm not the person that came up with this method. The actual guy did this like hundreds of years ago. But anyway, it doesn't matter. The idea is just kind of illustrating this. Computational thinking is a really hard thing to teach. It's something that you developed. You can't just I can't just say, here it is, go for it. But also, in order for you to learn, it's going to take time. A lot of time that we don't really have. That's like something you learn at simplest over a semester. Another thing is like you could say that it's something that you develop for the rest of your life. But it's good skills to have in this computer age that we live in. So I encourage you to do it. Like I said, people in the biz, they use this. Like there's a story about that I've heard for using, like somebody was needed a search algorithm for across multiple servers. So then they broke it down into the different problems, and they reached out to people and said, hey, we have this problem. And somebody said, you know what? We have just the thing for you. We've been doing this thing with honeybees, and we think we can apply this stuff that we've learned to your problems. It addresses each one of your problems. Let's do it. And so they came up with an algorithm, and it worked. I mean, it's, as far as I know, it's proprietary, so it's not something that I could just show it to you, but I don't know if it would help you that much. But the idea is they came up with an algorithm, and they said, hey, you know what? We could apply this to other, we could sort of apply this similar algorithm. We could like tweak some things and have it work on for other companies, for other things, whatever their different needs are. So that's the level of abstraction. So it's that story. It's happened. The honeybee algorithm, it's a thing. And it kind of followed this process. Anyways, that's all the content that I wanted to talk to you guys about. Just as a reminder with the video, 4 to 6 minutes long. Make sure you submit a video file format. One of the questions I answered a bunch in class today was, can you use a Zoom room to record? Yes, you can. You can use Zoom to record your thing. It's a good way to do it because you can do a PowerPoint or Google Slides or whatever and have everybody there. One person just goes through and you record. That's a way to do it. If that's how you guys want to do it. And feel glad about yourself. Okay? Anyways, I think that's good for today. I will see you all Wednesday. Bye. Hey everyone, I hope you enjoyed that video. If you did, please press the like button. It lets me know I'm doing something right. If you have any questions about any of the content, please send an email through Canvas to me and the rest of the teaching team, and we'll get back to you as soon as possible. Do not send it through normal email. You will not get as fast response. These are COVID times, so it could take a little bit, but we will get back to you, I promise. Anyways, if you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for when I post the next video. Anyway, I think that's good for now. I'll see you all next class.